Every time you tap a transit pass or swipe a payment card, invisible digital networks instantly extract your data. Yet the devices making this high-speed exchange possible, the NFC chips in your credit cards and the RFID stickers on products, have absolutely no battery inside them. If we look closely at this diagram of a passive RFID tag, you see a tiny microchip to store information and a coiled metallic antenna to communicate. Notice the empty space. There is no internal power supply whatsoever. In a modern world driven entirely by electricity, a microchip without a battery is an inert piece of metal and silicon. It cannot process commands, and it cannot transmit signals. It is completely voiceless. To transmit your data, these tags have to steal energy directly from the air around them. They borrow power just long enough to temporarily wake up and become ghosts in the machine. To understand how they get that power, we have to look at the first half of the transaction. We call this the interrogation, and it starts with the active half of the system, the reader. This shows a reader emitting an electromagnetic field, like an invisible flashlight of radio waves. When a dormant tag enters that field, the waves wash over its coil. This energy pushes electrons inside the antenna into motion. This silent transfer of power relies on a principle discovered in the 19th century by physicist Michael Faraday. He called it the law of induction. Using copper coils like the ones pictured here, Faraday demonstrated that a changing magnetic field can pull electrons across empty space, inducing an electrical voltage in a separate, completely disconnected conductor. Back in our modern microchip, the antenna captures that raw, alternating current radio signal. The circuit quickly flattens it out into direct, usable power and feeds it straight to the microchip. Instantly, the device is alive. Now the chip has power, but there is a severe mathematical limitation. The tiny amount of electricity it just harvested is nowhere near enough to generate and broadcast its own radio signal back to the reader. So the device doesn't try to speak with its own voice. Instead, it takes the powerful radio signal already hitting it and manipulates it. This split screen shows RFID backscatter. Instead of actively broadcasting, the passive tag alters how it bounces the reader's signal. Imagine shining a flashlight at a mirror. Rapidly tilting that mirror chops and changes the reflected beam. The tag performs the exact same trick with radio waves. It rapidly changes its antenna's electrical properties, switching between absorbing incoming waves and reflecting them. The reader detects these disruptions, translating the choppy reflected waves into binary, decoding your data. This method requires close physical proximity. Near-field communication, or NFC, relies on a maximum distance of less than 4 centimeters. Keeping the reader and the tag that close ensures highly targeted power transfer and naturally prevents unauthorized devices from intercepting the data. This resulting echo allows an entirely voiceless microchip to process and transmit complex, encrypted information flawlessly, without ever spending a single drop of internal power to broadcast a signal. Every simple tap of a card actually triggers a hyper-fast loop of parasitic energy transfer and mirrored radio signals. Because they never require a charge, these microscopic devices have quietly rewired the physical infrastructure of global logistics. Major retailers like Amazon use this battery-free architecture to identify and track millions of warehouse items automatically. They cut out massive amounts of human error, and the tracking nodes never require a single battery replacement. Engineers are now pushing this concept even further. Soon, sensors will not even require a dedicated payment terminal or scanner to wake up. Experimental tags are being designed to harvest their power directly from the existing ambient noise of our cities, pulling tiny amounts of electricity from the Wi-Fi signals and cellular networks already filling the air around us. We are building a permanent, invisible grid, a dense layer of digital intelligence capable of running endlessly on the background radiation of the modern world.